Hello and welcome to this CES coverage from Digital Foundry. Today, I'm joined by Tom Petersen from Intel. We're here in the Venetian talking all things ARC, Panther Lake, and much more. And Tom, thank you once again for joining us.
It's great to see you, Alex.
Yeah. I'm going to start with the heavy hitters that are a little awkward at first because we have to break the ice.
Great. Just warm me up.
What's with Big Battlemage? When are we going to see Big Battlemage?
When are we going to see Big? That is a fantastic question. And I'd like to get that out of the way right away. I cannot comment on unreleased products or unannounced products, but it's an excellent question.
Okay.
And I know a lot of people are curious.
Okay. Well, I had to get it out of the way. But seriously, though, kind of surprising until XeSS 3 announcement. I actually didn't expect that. You guys have been iterating over the last few years since you've done it, but what was actually the initial blocker from going from FG to MFG? Like, what was that internally? Why did it take time? And what was the advancements that were needed to get it out to market?
Yeah, that's really interesting. I mean, obviously, when we're changing an algorithm, it takes just development time. So as soon as we got done with our two-way frame gen, we began work on our multi-frame generation. Mm-hmm. And that requires, some new thinking. You need new models, you need new architectures, and you got to figure out ways to do it optimal. So you may remember that we do an AI calculation of optical flow, which we use for our sort of, our generative process. Now we only do that optical flow model one time. We use that same information for every interpolated frame. So it just saves a lot of performance. So it's that kind of development that our team just takes time to work through. Mm-hmm. There was no particular technical hurdle, I don't think, other than just a lot of engineering work.
What about frame pacing, though? Because you're essentially inserting frames in between the real, quote-unquote, real frames. Yeah. Do you know how you're doing frame pacing? Is it in hardware? Is it on the CPU?
It's software. Software? So frame pacing is absolutely required. You can't do frame generation without frame pacing. Maybe I'll show you a timing diagram of what it looks like. But you can see it's very bursty, right? It takes a long time to render the base frame. And then it takes a little bit of time to do optical flow. And then the other interpolated frames are very quick. So if you didn't pace that out, it would look really, really not great. So frame pacing is essential. And I would say that we're really just at the beginning of this whole understanding of how to make synthesized frames look their best, and frame pacing is clearly part of it.
All right, so we're right now at this point where we've moved to frame gen, and we are moving up the amount of factors that frame gen is having. You guys are touting now 3 generated frames, 1 frame, real frame. I don't like saying that.
Rastered frame.
Raster frame, maybe. Where do you see the future of this going exactly from your position? We're going to have 1,000 hertz monitors soon.
Yeah, we already do.
Where would you like to see frame gen going actually in the future?
I from my personal view, and I think this is still in the research space, but I think VR does a pretty good model of how this could end up, where there's an engine that's responsible for presenting frames that's always perfect. Mm-hmm. So the engine would be perfectly aligned with a monitor's refresh rate, and it never misses. So think of it like a small reprojector and a small pacer. And then the generator process would be sort of orthogonal to that. So the question is, how many frames should you raster? How many frames should you generate? Doesn't really matter. The reprojector is always going to make it perfect to the monitor. So there's lots of interesting ideas about decoupling sort of the raster and the generating process from the sort of the projection process.
Yeah, I could see that coming too. Do you also see a future for extrapolation in there at all?
I think extrapolation is a great technology. It's super hard to get to work right. But if you can do anything to reduce the latency that's apparent to users in this entire frame gen world, I think that's worth investigating. But I do think that there are other techniques that are not just extrapolation that will help reduce latency. And for me, I split it into 2 big chunks. There's latency that is sort of click to photon latency, where you did an action and you're looking for a result. There's not much that we can really do to make that look faster. But with the other type of latency, which is, you moved your eyes or you moved your gun and the screen needs to move, that kind of latency can be dramatically improved with multiple different techniques.
Like, what do you see in your mind for that? Other than your proprietary, low latency Intel LL.
Well, there's definitely that, right? Yeah. But beyond that, if you think about what you're trying to do, you're trying to put the viewport into the correct position so that when you render, you're rendering a future view. Right, and that's all about prediction and accurately predicting where the view will end up being when a person is actually going to see the frame.
Yeah, So you also mentioned as part of that, the initial optical flow being a larger step initially, and then the generated frames maybe being taking a smaller amount of time.
Yeah.
How do you see, now that Panther Lake's out and it has integrated GPUs in it, do you see some sort of cooperative support there between a dedicated GPU and an integrated GPU to take over this process?
You know, we looked at that back in the day earlier when we had discrete and integrated all together. Right now, and we never could get that to work well. And it's because there's a limited power budget for the entire platform, and they tend to fight against each other. The real I think solution is going to be something that's more about multi-threading of graphical processes. Maybe think of it like you have two different renderers running in parallel on the same engine, perhaps.
That's kind of FG at the moment. I did try it out earlier. I was actually quite impressed on the low power profile. I actually didn't believe first we were doing the 4X mode, which is a very good thing.
Yeah.
I was only using a controller, but I think that speaks quite well to the quality.
Were you doing like a smooth scroll kind of thing?
I was doing a smooth scroll, so I was, but yeah, also some more erratic movements. I think that speaks to the quality, actually. So it's already pretty great.
It is. I mean, the frame gen stuff is very good. If you slow it down and take like pictures of it and step through, you're still going to see artifacts. But the artifacts, to me, don't distract from the improved experience. And we had a lot of questions going into it, whether frame gen is appropriate when you have relatively low rates of raster. And it turns out, you can see by the systems here, integrated, which does have relatively low rates, benefits tremendously from frame gen. The experience is much better. But we're also important to say it's not the same, right? Generated frames are not the same as rastered frames. So we very clearly indicate that in all our material. We talk about our raster performance separately from our frame gen performance. And most of the time we think of frame gen frames as smoothing frames.
So latency, though, in general, do you feel like that is the larger hurdle in this, or the like visibility of frame gen errors that is like the biggest hurdle going forward?
Like what's the resistance? That
what's the, because in the audience,
there's definitely
we put out videos about DLSS 4.5 or whatever, and we talk about FG, and a lot of the comments are very derisive toward FG in general.
Yes, I think Nvidia's had a hard time.
I can imagine.
I'm sorry, guys.
Like, what do you think is actually like the hurdle towards wider adoption among audience?
So I don't ever throw others under the bus,
right?
But I think this started off on the wrong foot, where we were, some people were trying to make this sound like it was performance, right? And I think the pushback from the community is saying it's not, right? We don't think of it like performance. So I think that's the bigger thing. Like let's separate it into its own space and say what's happening is a visual improvement effort. It's different from the horsepower of your car, right? The horsepower is the horsepower, and it has its own spec. But this is like trying to make what that horsepower engine does feel better.
Yeah.
So I feel like it's a little bit of the position that it started in. So we're trying to do our part by saying, hey, these are very clearly different, and we like to think of them as different things. That's what animation error is all about, actually. Trying to help separate FPS from smoothness.
Yeah, I think that's a good transition point. Thank you, Tom.
Yeah.
So we talk about stuttering a whole lot, and I'm going to have a lot of questions about this actually. But we talk about stuttering a whole lot at TF because I think it is one of the biggest issues in modern games from a tech reviewer's perspective.
You and I are cut from the same place.
Yeah,
I agree.
And you have made, through PresentMon, Intel PresentMon, you've made various advancements to try and communicate that to both tech reviewers and audience. So,
when it's dark out, I'll light a candle.
Precisely. How do you want the audience as well as tech reviewers to explain, like, to understand animation error best? Like, how can you do that with PresentMon?
Well, that's an excellent question. I don't think, I have done a great job explaining this problem. And I think Gamers Nexus did a great video, so thank you, Steve.
Yeah, they're great.
But there's a lot more here to talk about. And I think it all starts with understanding what is stutter, like what is physically happening. And I think that has to do with like a lot of slow motion videos and understanding the game pipeline and how that generates frames. So we're trying to do more of that. PresentMon takes that metric now as part of all of our releases of PresentMon and makes it accessible to everybody. So you can get it as part of our overlay, or you can get it into the CVS files. I'm assuming that all the derivative tools that use PresentMon, which was things like CapFrame X,
yeah.
and FrameView will also present that information out to users. Now, I feel like it's too early to say that's baked, right? We're just like, we have the math working, but we don't know really what the thresholds of good and bad are. So I encourage everybody to just, start giving us feedback. We want to have people use animation error, look at the results, and then give us feedback about what's good, what's bad, what would we change. There's other problems, which I'll also say. Animation error relies on a calculation that I call animation delta and display delta. The display delta is time from frame to frame, and that's very well known. The animation time step is harder to calculate, and we're relying on games to tell us timestamps with every frame, but that's not a common universal thing yet. So I'm working on an API that we may someday make available that's just a performance API, and it's not any effect. It's just if you integrate this API, you'll provide presentment all the markers that we need to accurately calculate your performance profile.
I personally kind of see a future where we move beyond FPS and we start talking about image persistence, latency, and smoothness as categories.
Yeah, I think so.
And I feel like you pushing PresentMon in that direction is actually a really great thing.
Hey, thank you. God bless you, Alex.
Yeah, we've been talking about FPS for too long, and I think it hasn't represented the gameplay experience for a long period of time.
Especially as we're more into this world where generation is really significant part of the experience. Is FPS really the right word for that, right?
Yeah, I don't think it is. Okay, so you have PresentMon, and you're going to move in that direction, but there's other sources. There's many sources of presentation stutter in games. You've talked about animation error, but the reasons behind the game stuttering are multivariate.
Oh, huge.
So one thing we've talked about at DF as a part of the stuttering, our crusade against it, is shader compilation stutter.
Sure.
Do you know Intel's stance right now on advanced shader delivery from Microsoft and how you want to
We are obviously very much supporting it. We also have our own sideband right now before that really matures.
Oh,
so,
yeah?
Yeah. So we do precompiled shaders in the cloud, out. And we'll actually download those to your local PC if you're running our control software. And so when you first run the game, you will have precompiled shaders.
So, and this covers DX12 Vulkan?
Damian, what's this cover?
DX12 at first.
DX12 at first.
DX12 at first, and do you have a rollout date for this?
So it's out with Panther Lake, right?
It will be out with Panther Lake, with the review driver, and then on-shelf availability will be.
Yeah, now the game list, I think we started with Steam, is that right?
We start with Steam games, and there's going to be a list of games that we support at launch.
Okay.
And we'll, extend.
To reiterate for the audience, there's going to be a list of games that will be supported at launch. Panther Lake, DX12 at first.
Yep.
That is actually incredible. Now, how's the mechanism exactly working? So you have the shader compiler for in the cloud. You guys do it, and you distribute it asynchronously or with driver updates?
It is asynchronous. Okay. So there's a service that's running on your PC that is querying, basically looks at the games you're playing and says, what do I need to download? Yeah.
So how are you getting the shaders then from the game? Like, are you
every time a game revs, we have to recompile the shaders.
Okay.
Right. So think of it like it's a heavy lift, right? You can't just say we did it once and we're done. That's not the way life works. When there's a game update, we have to update the shaders and you have to check all the versions.
And are you getting these from telemetry from playtesting QA or developers supplying them to you?
Oh, you mean like
where the shader cache is coming from, like the initial ones that you are
Well, the shader caches come from our compilation.
Okay.
Right? We compile it, put it in a database that's in our server, and then we download it to PCs based on our local software.
Oh, okay. Sorry. Let me reiterate. Where are the initial list of PSOs coming from that that are there that should be used for the
Right.
title?
So how do we know which shaders to compile for the game? We do our own gameplay.
You are doing your own gameplay.
Yeah. So effectively, you have to run through the game to get the shaders all compiled. Now, I don't know if Alex has any magic. Alex is the guy working on it. I don't know if there's any magical scanning thing that he's doing. I don't think so. I think it's just gameplay based to get the PSOs.
This is incredible. I've joked in the past about a so-called shader butler, as in someone who just goes and plays games for you to prevent the stuttering from happening.
Yeah.
And Intel is apparently
we're working
on
it. I mean, it's a big problem. It does have an experience effect, and we're all about making our integrated product more and more acceptable for gaming. And I think with Panther Lake, I don't know if you saw our data, but Panther Lake is delivering the performance of a 4080.
Yeah, yeah.
So I'm sorry, 4050 on mobile, and that would be great if it was.
That would be sick.
Yeah, that'd be like nice job, Tommy. Yeah, so it's a 4050 already, which is kind of a mass market just a couple years ago.
Yeah, it is. That is actually really great that you told me that. I didn't expect that, and I feel like that is quite unique position. We have yet to hear from any of the other vendors about their movement on advanced shader delivery beyond the ASUS Ally Xbox. I forget the name of the device.
I think eventually Microsoft is going to have a solution here that scales larger.
Yeah.
Right. But it's just a question of what's the timeline on that. And so for us, we're doing this to improve experience now because it's a problem for our gamers.
Yeah, it is a huge problem. And I feel like, wow, seriously, that's actually a big movement forward in it, because I've been railing against this for years, and there's obviously on the developer side about making sure your games actually have a small list of PSOs in general and don't have an explosion, but the IHVs moving in a direction is also very positive.
Yeah, I would love for this to not be a thing, which means that you would have shader compiler technology that was so good that you wouldn't ever have shader compilation delays. But that's just not practical right now because these shaders are gigantic. So the alternative is let's do some offline compilation.
Yeah, do you see, at least in terms of the gather process, you're pushing AI and ML. Do you see that in a future here to alleviate the issue even further beyond what you're doing?
I think there's a whole question about what's the future of game look like, and what's the combination between raster and AI, and would you in that world have fewer shader programs and more AI networks? And I think that's definitely true, where you'll do more of the process of rasterization using AI assists.
Yeah. I've got a question about that in a second here too, but how do you communicate to users what are the performance problems with their game?
That's another great question, Alex. Well, we've been trying, right? This is another very hard problem because it goes from very simplistic, which is FPS, to slightly more complex, which is things like animation error. But now people want to know the causes. So if you look at PresentMon, we've done two things. We've added all the telemetry that you normally get from a GPU. That's all part of PresentMon now. So you'll see temperature and utilization and all the different ways to break down a GPU. But we also look at what the render process looks like on the CPU. And we have a metric called CPU busy and GPU busy that gives you a sense of which part of the bottleneck, which part of the pipeline is bottlenecking you. But even that is just the beginning. And so we'd like to get to the place where you can imagine you open up PresentMon and you're getting a sort of a real-time diagnostic assistant that is helping you tune your game, like tune your system to eliminate bottlenecks and eliminate stutter. That's a ways away.
Yeah.
But right now we're just providing the building blocks for all that.
I talked to Nvidia about this too, and I feel like that is the future, because at the moment right now you go into a settings menu in a game, and unless you're watching an optimized settings video by some expert,
it's overwhelming.
You don't know necessarily what's causing it.
Yeah, I think they've done a great job with their current version of GeForce. What's it called? It's called the Nvidia app now, or whatever.
Yeah, whatever it's called. Yeah.
But they've combined the game settings with their control panel settings, and they make recommendations. I think that's the way this is all going to go. And eventually, some AI assist that sets that up automatically is probably coming.
Yeah. So we just talked about CPU busy. This year, and in the past, you've made great strides within the driver to reduce the CPU limit.
Yes.
Essentially, beyond just measuring the deltas between driver versions, can you give a bit of insight about how that was achieved at Intel?
Well, again, I'm going to give credit to Alex's team. I just saw an incredible demo where as the performance profiles become more clearly CPU limited, they've really dug in on that. And it's things like caching and offloading and maybe doing multi-pass compilations, that kind of stuff, really changing the profile of the driver. So I think that you're going to continue to see improvements. Nvidia's been working on their DX9 driver for 30 years? We're still working on it, It's pretty good.
That's something that's also improved. DX9's performance and DX11 performance.
Night and day.
Night and day from launch, when games maybe wouldn't be running at all.
Hey now. Well, I don't know what you're talking about there.
Just for a little bit of retrospective, since we are talking about that.
But that's not that long ago if you think about how far we've gone. And that's all because of the software team. You guys doing some great work.
Yeah, they've done an amazing job since launch. But I kind of want to talk about that initial ARC post-launch area because it was such a fun time.
Let's go, Alex. I do love that.
How do you feel about XeSS DP4A in hindsight?
I think it's a necessary technology. So XeSS, DP4a, I think we could have done a better job communicating about what XeSS is. And the problem you're alluding to, just for everybody, is that there are multiple different models that we use for XeSS because there's multiple different hardware platforms that we run on. And those models have different artifacts. They have some have a little more blur, some have a little bit sharpness, but they're just not the same. So we had a choice of creating multiple names for everything, or just calling it all one thing and kind of waving the hand. So we decided, and I think it's probably the right call, there's just one thing called XeSS, and it represents our AI super sampling technology. And there are multiple models that are different on multiple platforms, and they have multiple different artifacts. It even gets worse, though, because we have multiple settings within each model, and they all have different performance profiles. So it's almost like an intractable, complex problem. And so rather than trying to be super accurate, we just kind of simplified it a little bit to keep it understandable.
So, okay, so XeSS comes out and we have already on the market FSR and we've got DLSS, and devs have maybe not a straightforward interface to plug these things into their engine.
They don't.
And do you see a future there to make it more simple for devs, as well as the opportunity now that everyone has ML hardware to make these things more cross-platform?
Yeah, I think you won't see many algorithms that are cross-platform because that's an area of differentiation for all of us. We've been slightly more open than most of the vendors, but I do think DirectML is going to make it easier to have common infrastructure so that it's more possible to have cross-vendor paths, but I don't think the market is incenting that behavior.
Not at the moment.
What the market is incenting is a common framework for developers. So something that is plug and play where effects can be plugged in without repiping the entire render pipeline, that is an obviously important issue. And I think Nvidia's done some good work with Streamline. We wanted to do that, but it's just not quite where we need it to be. So if Jason, you're listening, I still want to work with you guys. But there's some issues that have to get solved before it's truly vendor neutral.
Yeah.
And it's not.
What about DirectSR?
I think DirectSR is a good model for, we want to work with Microsoft. We would like Microsoft to solve this problem. And the problem is, what's an effects API that we can all just code to, just like DirectX?
Yeah.
It should be called Direct Effect or something like that, right? And if there was Direct Effect, we would all use DirectML to code our stuff or whatever we wanted to code it into. Developers would all self-discover the effects and everybody's happy.
Yeah.
But that's not happening. So DirectSR, I think, is a step forward, but I do think there's another step that's an investment that I hope Microsoft makes.
I also was hoping a little bit that DirectSR would be a bit more future-looking because it covered mainly the SR portion.
Yeah.
And we really were looking for like some sort of common way to inject low latency reduction in games, FG, and potentially things that are like combined upscaling with
and I'd like to see add performance into that too. Like,
please.
give me a performance API, right? Because that would help all the downstream tools.
Yeah. So these variety of ML technologies, you guys now are running with FG and an SR solution. Where would you like to move on to next? Because a number of years ago, there was a rather great demo of a combined SR and denoising solution from Intel. And there was a presentation on it, but we haven't seen anything since.
I do think denoising is a thing that is important because it does make ray traced worlds much more accessible with the hardware that's available today. So I think you'll see denoise continue to be important. But I also feel like this smoothness, we haven't really applied AI to the fundamental problem of smoothness yet. And that would be a cool thing, right?
Like, what do you iterate on that? Like, what do you mean? Like,
well, I keep saying that smoothness is a mismatch between the position of things and the time that you see them.
Yeah.
Right. If you could correct the position or correct the time, that would be better, probably. Right. Yeah. So that means that if you could have something that was correcting the timing, even though the position was wrong, that might be good.
Yeah. I can see that. Like you were just describing once again earlier, this like decoupled model of present and everything. Yeah, that's definitely a future.
It could be good.
It could be great.
Yeah, but even if you didn't have that model, it's just like the next generation of frame pacing.
Mm-hmm.
Right?
Yeah. Coming back to frame pacing a little bit, FCAT was a big thing for a long time. I think we are one of the few people that actually still look at it at all anymore.
Do you still use it for like Xbox stuff?
Well, we for Xbox and console, we actually do like a post analysis of the frame, and there's no markup at all. So it all has to be done an inferred basis,
basically
image
look at the
properties.
pixels?
Well, yeah,
Oh, wow,
pixels,
okay.
and so it cannot be perfect for things like tearing, unlike FCAT, which is perfect for tearing.
Yeah, great.
But I feel like that's where PresentMon once again comes in and says, no, this is actually what your real frame time is.
With PresentMon, we are closely coupled to the render pipeline, and we know exactly what's happening. FCAT was before all that information was available. So FCAT was like, how do we get a good proxy when we don't have connections in the guts? Now we have connections in the guts.
Now you got the connections. Okay, so denoising, originally ARC was billed, and I think its architecture was aligned to it as a path tracing forward-looking GPU, but we have yet to see, I would say, really unlocked path tracing performance on ARC GPUs. Do you feel that that is just the market segment you guys are targeting, or is that more architecture iteration is needed there?
I don't think there's anything that prevents us from doing it. Looking at the architecture, my understanding, and I think the architects would agree, we're okay for doing path tracing. It's just a question of what is the most important thing for us to do now with our limited resources. Path tracing is still generally a big GPU problem, right? It's not something that you do with smaller GPUs, or certainly not integrated. So because of where we are positioned from a performance segment in the market, I don't think path tracing is our primary focus.
Okay. If you had to iterate on DXR in the future, because right now we just saw DXR 1.2 support across vendors is still somewhat of a question mark from the consumer-facing perspective, but I think it's actually known amongst developers. But things like OMMs and SER, is that stuff going to be supported on current Intel GPUs, future Intel GPUs?
I don't know the answer. That's an excellent question, but I don't know the answer to that. I don't know if any variant of DXR actually has a hardware different. Do you know, Damian, is there a hardware dependency on different versions of DXR?
Yeah, there is.
There is. And so I suspect we have to do a tweak to support future versions, but sadly, I'm not an expert on that.
Okay. And just a quick question, maybe you would know it, but the new work graph support, is that like
we care about
shader models? You care about work graphs?
Yeah, everybody cares about work graphs. Yeah, because it's just obvious that that's going to become a very important part of raster going forward.
Okay. Yeah. Some other kind of slightly tangential support I'm thinking about right now, like Linux support, because we're talking about Linux more and more every day at DF. Do you want Linux to become kind of this thing where it's Valve curated? Do you want it to become Intel curated?
So you're talking for gaming.
For gaming, you're talking because the driver situation at the moment across vendors is very different.
Yeah, well, I think we're in a relatively good place relative to our Linux implementation for gaming.
Yeah.
But I do think, again, Linux gaming is not our primary focus. It's mostly Linux is our compute kind of OS, and that's where we're going to see a lot of our GPU compute products. But it's not really right now the most important thing for gaming.
Yeah, it's still such a small market share.
Yeah,
it's mainly
but it would be great if it got better.
Yeah.
Right, and I'm just not deeply connected to that enough to know what is the gap.
Yeah. So we've been talking about graphics as it is today. In the presentation we saw yesterday at the launch event, it was described as modern rendering, which I thought was a nice moniker.
Yeah,
it wasn't bad.
Was that you?
But what about the future of rendering? Because we've seen demos, and Intel actually supported the texture compression, for example, neural texture compression.
Cool.
Where do you see the future of graphics?
Like what's modern rendering in the future?
What's modern rendering to you, and what is the future of graphics to you?
That's, again, a hard question because I don't know. But from my heart says we're all questing towards that nirvana where there's a photorealistic image that has no perceptible defects.
Right
now, in the past, we've gotten that to work by a million tricks, sleight of hand, ambient occlusion, all these sort of like painted on effects. And ray tracing changed how a lot of those were done and moved it from sort of like these artist tricks to a little bit more like physically light-based evaluation. I wonder how many more of those things can move to improve realism. And I think that's going to continue to happen. But I don't think that's the primary thing that's breaking immersion right now. It's this whole stutter thing. It's the whole. So that's where I am interested most, is how can you make it look like butter? So a couple of years ago, and I think you're probably aware of this, I don't remember, is it a Google project? I think it was a Google project on the Android phones, and it was called Butter. Really? And what the project was all about is like, how do I make it so that when you scroll, it is pristine, right? You cannot see it looks like paper, right? That's what I would love to do first for gaming, is like, how do you make it so that your gaming experience doesn't have any of the problems that you do by translating artist intent into an image? And there's still lots of work to do there, right? Mm-hmm. So AI is going to play a part of that. But it's not just AI, it's going to be better raster techniques and better display techniques and better delivery techniques.
Display techniques. We just saw the announcement of G-Sync Pulsar. Yeah. You were intimately involved back in the day.
I know a little bit about
all
that.
Things G-Sync, all things ULND.
Congratulations to Garrett. That's pretty cool technology.
It's cool tech. Does Intel want to move in on the monitor space in this direction, actually?
Well, we actually do have a very large influence on the panel side of the world, right? Yeah. Because of our laptops' dominance. So I think you're going to see continued innovation on the laptop monitor side. And there's lots of cool opportunities left on displays. And I think, G-Sync is obviously a good step forward, but there's a lot of new and different techniques that are similar. Like back in the day, I knew when G-Sync first rolled out, I did a chat with John Carmack. I went to go visit him. He was in Dallas at the time. Did I tell you about this? He's obviously a genius. And we sat down and he told me about something that was on his brain for a while. I'm like, I'm going to remember that. And so I've still got that one. So this is but there's a lot of interesting things related to human perception and displays. So the truth is that you're only ever looking at one spot, and that one spot is dense on your fovea, I guess. And the rest of it is really peripheral vision. So can your display react to that? Probably, right? Yeah. And what would you do? And another fact is most of the time you're looking at the center display. So you're not really looking at the edges very often. Can you use that? There's lots of interesting kind of human eye physics that have not been applied to displays yet.
No, and they've only been very tangentially in the HMD space.
Yeah, of course. VR. Because that's the perfect place, because you know where the eye is. Yeah. And you can actually track it pretty accurately. You can do, I saw some early eye tracking demos a couple years ago. They were pretty good, right? Where you could actually see, a little detector on the monitor looking at the eye, and that is where the pixels were, right? So you apply your raster to the portion of the image that is being viewed.
Yeah.
And the rest is almost like a sort of a fill.
Yeah. That's a technological direction that has sadly not been so exploited.
It's hard. It's really, really hard, because that means your computer is only viewable by one person.
Yeah.
And that person needs to be sitting right in front of it. And it's hard.
It is hard. There's been a number of directions where technology hasn't really gone, even though you thought it might.
I can't imagine how many bombs I've had technology-wise. Like millions of them.
And I actually...
Yeah.
Sorry, no, go ahead. I think back about DirectStorage coming out, because on the console space we have essentially a dedicated hardware block with very specific formats that are decompressing, from your SSD directly into GPU memory.
Right.
In the PC space, we've got a split memory pool and the PCIe bus. Do you see in the future potentially these large divisions in system memory, VRAM, and PCIe bus kind of being nivelated a bit, kind of being...
I don't know, that's a tough one. I know that Microsoft was doing quite a bit of work on DirectStore, but I think that's been kind of
Yeah, it has been de-emphasized.
Yeah, and I don't know of a next version of that coming.
Yeah.
And I don't think it's because they don't care about the problem. It's just absolutely really hard to solve, because you have to get agreements across all the vendors, because you're doing the decompressor. every vendor's doing their own decompressor.
Yeah.
And we all have to agree.
Yeah.
And that's just really hard.
Yeah, that's, I mean, they have to wrangle everyone, essentially.
Yeah.
It's
And
not
everybody has that one little thing that if we only put this into the compression standard, it would run great on our stuff. And that just is really hard to manage.
Yeah.
The fact that we have movies that are compressible is shocking.
Yeah, that goes back a bit into your statement you said earlier about like smoothness. I feel like perceptual rendering is perhaps another way
I think
forward.
that's a great way to think about it.
Yeah.
Like if right now we're still in that, hey, let's get higher performance.
Yeah.
And everybody thinks of performance as FPS. And I'm hoping that at some point we transition to how can we generate the best experience? And that's not FPS. It's something else.
Yeah, it's something else. I mean, I'm kind of exhausted for questions at the moment.
Oh, cool.
You're so good at this.
Oh, come on.
But this is a lovely conversation. I could probably pick your brain on a lot of other topics that
Yeah.
just don't come to my mind right now. But specifically regarding Panther Lake, you're moving forward now on laptops,
Handhelds.
handheld.
Yeah.
Well, I haven't seen a handheld yet today.
Have we got a handheld here? Yeah, we got one in the ArcZone. Come by ArcZone.
I'm very excited.
It's a Lunar Lake? Okay.
It's a Lunar Lake one. Well, I think that is another untapped industry that is going to be moving forward that we're very interested in Intel's work in, because we've basically been seeing AMD dominance there.
Yeah, I don't think that's going to be the case going forward.
Yeah.
And it's as this market has matured a little bit, it's become a little bit more of a real market rather than an experimental market.
Yeah.
I think Dan announced that we are doing a reference platform.
There's going to be a reference.
Ecosystem. He said something about ecosystem thing, right? Yeah. Okay, but but I'm excited because Panther Lake is so high performance with a display that's high resolution and small form factor. You can run for a long time playing whatever your tier 1 title is because we got enough performance, right? It's pretty cool.
Yeah, we've just been looking for that competition in that space, because I've said it a number of times on DF Direct. I'm kind of bored of the latest releases in handhelds because they're very similar to each other, and just that innovation wasn't there. And I think Intel actually brings that to the table.
I think we do.
Yeah.
And it's a learning market, so there's a lot of innovation left there, and the whole OEM, ODM, ISV, IHV ecosystem has not really matured yet. There's still lots of independent UIs that are a little.
Yeah, we really need the OS to kind of.
You would like to have a OS oriented, almost like the Steam one, right? What's big picture?
Big picture mode, SteamOS.
Do they have a handheld version of SteamOS?
Yeah, of course. Yeah.
Yeah, but is there like one for Windows?
Oh, well, not yet.
Not yet.
Yeah, it's in the making at the moment.
Oh, is that
Microsoft. Right? Yeah, and we've tested a bit with the Xbox ROG Ally X, and it still needs a lot of iteration.
And I think right now the OEMs are reaching out and doing a lot of their own development for those UIs.
Yeah.
But hopefully that whole ecosystem will mature as the volumes get more significant.
Yeah, I'd hope to be that the way too, because this is like a new segment, new frontier.
Yeah.
We're going to see the consoles moving in this direction. Switch 2 is already doing it, and we need that on PC. I think.
Do you know is Switch? I haven't looked at Switch 2. Is it an OLED?
Currently not. It is right now a Oliver.
It's an LTPS LCD, I think.
It's an LCD.
And is it variable? Do you know if it's a variable refresh?
It does variable refresh to 120 hertz.
Yeah. So
But devs need to implement LFC.
Okay.
Yeah.
Is it branded G-Sync?
It is branded G-Sync.
Is it?
It is branded
No
G-Sync.
way.
Yeah,
God.
Yeah, we know
kills
about
me.
that.
Kills me.
Yeah. So they're definitely. It's impressive that they did get actually G-Sync or VRR on there.
Yeah.
But that's another field that I feel like could also see some innovation. I'm very happy to see G-Sync Pulsar. But,
No, I think there's more to be done on displays for sure. We're going to be focusing much more on handheld and notebook style. I know Nvidia is kind of doing discrete desk, kind of other stuff. And who knows?
Yeah, who knows? Well,
who knows? They made an investment.
They did. Yeah, who knows? But Tom, this was an amazing chat. I'm so
great
grateful to
see
see
you.
you, and I hope to see you in Berlin again soon.
I will be there as soon as I possibly can. Yeah. I loved it.
Yeah. But thanks for watching this video, everyone. Have a good one.